Good morning. Happy Wednesday. In this video, we're going to continue to focus on working on dilations. Again, as we started to learn yesterday, the dilation, let me just spotlight this for a second. The dilation is something that changes the size of a figure by making it larger or smaller. And yesterday, we really started focusing on how can we determine the scale factor, and we also started talking about the center of dilation yesterday. Today we're going to keep going on that work, similar practice, and we're also going to work on performing our own dilations today. So for the first exploratory problem here, problem A, we were told that rectangle ABCD, this red rectangle, is transformed into rectangle ABCD, which is this smaller green rectangle. And the first question you were asked is which transformation took place and to explain how you recognized it. At this point, we'll remind you, you should have already read through today's objectives and key terms. Here are the objectives, here are the key terms. And you already should have tried to complete all of the exploratory problems, the purple box problems, A and B, with your partner before you started watching this video. With that being said, we're pretty quickly going to run through each part now for the exploratory problems. Again, our first question was which transformation took place here and explain how we recognized it. You and your partner should have recognized that the transformation that took place here was a dilation. The reason we can tell it's a dilation is because the size changed for the rectangles, or whatever figure, whatever shape we're working with. The dilation is that one transformation that makes things larger or smaller, so it's pretty easy to recognize on a graph once we know that term. As we'll go the rest of today, and part 2 and part 3 help us with this, whenever we describe our dilations, we want to be specific about two things. We want to be talking about, number one, what is the scale factor for a dilation? That tells us how many times larger or smaller the figure gets. And number two, we want to be focusing on where is the center of our dilation? If everything is shrinking or growing, what is the point that it's shrinking towards or growing away from? Part 2 asks you just to complete the following table, which looked at the side lengths for some of the original figure, what we'd call the pre-image, and some of the new figure, what we'll call the image, which is in green. So when we look at the original figure, the pre-image in red, the length of AB for red, if you counted that up, you should have seen was 8 units long. It goes all the way from -4 to +4, so as we jump by 4 and 4 more, that's a total of 8 units. When we look at the image, the green rectangle's line segment AB, we see that it goes from -2 to +2, and that's going to be a length of 4 units. When we look at BC, we see it goes from +2 down to -2, so BC had a length of 4 units, and the image of BC in green here is only 2 units as it goes from +1 down to -1. This table is key for me recognizing the red figure goes from 8 to 4 for side AB. For BC, it goes from 4 to 2. The scale factor was actually 1/2, and we recognize this because if we multiply each of these side lengths by 1/2, 8 times 1/2 is 4, 4 times 1/2 is 2. And when we're asked about the center of dilation, we'll discuss this more in class if you have questions, but we should be starting to recognize why this dilation was centered at the origin. We see point A shrinks towards the origin, point B shrinks towards the origin, point C does the same, point D, all of our points are shrinking in towards the middle of the graph or the origin, so that's where this dilation was centered. At this point, if you struggled on part B, we would ask you to try to do part B on your own based on our discussion, or work with your partner to try to do part B, so go ahead, feel free to pause this video as you work through part B now. For part B, you were actually asked to perform the dilation yourself. You were asked to take this purple rectangle, PQRS, and perform a dilation with a scale factor of 2. That means every side length is going to get 2 times longer. Centered at the origin tells us each point is going to be 2 times further away from the origin. And we're going to call the new image PQRS prime, and we're going to label that all in orange. Your job here today was to recognize when we double click and edit this graph, you can take this rectangle, you can drag it around, you can make it bigger or smaller. But once you click on the rectangle, if you get to the corners, see how my mouse changes to a little diagonal arrow? Now I can drag that diagonally. Here, I could make it wider. I can make it taller, things like that. So the big thing to recognize for math, we're going to double the size of PQRS. Right now, P and Q have a side length of 4. So the new PQ, the new width, is going to be double that, or 8. And we see the height is originally 6. If we double that, it's going to be 12. Now, if I look at point Q has an x value of 2, a y value of 3. So the new point for Q is going to be way up here. We're going to double 2 and double 3, so it's going to be 4 units above the origin, to the right of the origin, 6 units above. Same thing over here, a -2 and a +3. That's going to go up to become -4 and +6 if we doubled. -2 times 4 gives us, -2 times 2 gives us -4. And then if we take the y value, +3, and multiply that by 2, we're up to a y value of 6. We see the same thing on the bottom of this graph. Point S has coordinates -2 and -3. So that's going to double to be -4 and -6. And same thing down here. That became +4 and -6 because it doubled its distance from the origin. Like we predicted in the beginning, this goes from a side length of 4 for the width, and this becomes 8. 4 plus 4 gives us 8 units long for the new PQ. And we see this is 12 units tall, which also doubled. So as we finish labeling this this rectangle, we recognize that it's twice as large, and every point is now twice as far, or has twice the distance from the origin as its original point. We'll talk more in class about why these are not going to be congruent. They are not the same size, but they are going to be similar because they are the same shape.